Hello everyone, Nate Zaplater from Engineering Symbiosis AD here with another short update. I found excuse me, let me rewind that. As you guys know, I'm not really a big fan of making shorts because it's really hard to condense my body of theory into a few minute video shorts in a way that would be meaningful and completely understandable to the audience. But I did find the tactical usage of video shorts now. I'm going to use video shorts as a way of proving that I've completely mentally internalized the working logic of my body of theory, and that I actually don't need to make long form lecture videos to be able to describe it, though I will continue to make them because I feel like they're better at communicating the full breadth and different diverse tactics I have for experimental implementation. Excuse me. Um, on that note, though, I'll just deliver a quick short here. So the topic I just want to talk about for this short is endosymbiosis and exosymbiosis. So as you know, that my theory is literally called Symbionics, which means symbiosis and bionics. So just briefly, endosymbiosis describes a symbiotic relationship between an organism and another organism. So if you have an organism, whether it's macro or micro, that exists on the surface of another organism, but isn't parasitic, that's like an example of endosymbiosis. I can't think of one off the top of my head right now, but yeah, that would be an example of endosymbiosis. Like, or you think of what would be an example? Like fish in a coral reef, like how certain fish feed off of what grows on a coral reef. Like that would be an example of exosymbiosis because the fish would eat barnacles or things that grow on a coral reef. Then it would excrete fish poop, obviously, which provides nutrients for the coral reef and the other microorganisms around the biome of the coral reef system. So that's an example. Excuse me. So Symbionics is a form of exosymbiosis in the sense that the buildings have an external symbiotic relationship with the surface of the planet, e.g., the crust, which is the main source of biogeochemical cycling, besides obviously the hydrosphere or the ocean. Symbionics is also endosymbiotic, meaning symbiotic internally, because it's soft robotic or soft mechanical systems that would create the artificial internal biogeochemical cycles that would connect with the natural biogeochemical cycles, or what I have called urban natural biogeochemical cycles. because the soft robotic or soft mechanical artificial biogeochemical systems would incorporate living microorganisms that are necessary for freshwater purification or desalination for local North American ecosystems, especially speaking in my context for Southwest Ontario. So in that sense, Symbionics is both endosymbiotic and endosymbiotic. Thank you. Bye.